to the program for an ALP to perform the division operation on 8-bit number by another 8-bit number. As initial, we have taken the origin as 00H. This is the initial address, that is the initial memory address. Next instruction is move R0/30H, which is nothing but we are going to, this slash represents the immediate data. So this immediate value 30H in hexadecimal will be moved to the R0. Next, the @ of R0 represents the indirect addressing mode, as we have already told in the previous videos in arithmetic and logic operations. This is the indirect addressing mode we are using. The value what we have stored across the 30H will be moved to the accumulator. So once the value have been moved to the accumulator, the increment, that is the register R0 will be incremented, 30H will become 31H. Next, we are going to move the value. Once the value has been incremented, the other the R0, the value from the R1, so that is the 31H will be moved to the register B. So next is the important instruction, that is we are going to perform the division operation. Here, just like the subtraction operation, as we need to subtract the value of B from A, this is also similar to that. We need to subtract the value of A from the value of B. Many of you will get confused whether you are going to perform the division across the B and from A or from B to A. Always remember, whenever you are having the value, you need to divide the value in register B from A. Therefore, in A, the value will always be the quotient value and the remainder value will be stored across the register B. Once the division operation has been performed, we are going to increment the R0. So previously R0 value was 31, right? Now the R0 value will be equal to 32. So therefore the increment value, that is the accumulator answer what we had got, that will be moved across the 32H. So later on, from once again we are going to increment, so which means the quotient value what we had in accumulator will be moved to the 32H, and then remainder, that is across the B what we are having, that will be moved across the 33H. We shall see that and at the end of the program. Just like the previous one, select the program within the target. If the program is not available, go to the source group again and choose the assembly level program. It is important that whatever the program you are saving, that has to be in the .asm format. Here I have named the program as program 8. I am choosing and adding the same. Since I had already added, that is showing it as already existed here. Then go to build the target. You can observe here. Here we are having the 0 errors and 0 warning. Then move on to the debug. Start the program. We are having the memory location of 30H. Go to 30H. Here I am taking the value as FF and the next pointer address as 0A. Once we have stored the value, move on to the stepping 2. It will perform the stepwise movement of the instructions. Here you can observe the value across the 30H, it has been stored across the R0. Then we have stored the FF across this pointer, the value will be moved to the accumulator. You can observe here. Later on we are incrementing the value, that is the register that will be moved across 31. Next, that will perform the division operation. Always remember the dividend value what we are having, that should be always lesser than the division value for the division. You can observe we are having the quotient across the accumulator, which has been moved to the 32H, and this is at the remainder at the 33H. This is the end of the execution. Thank you.